We're going to do it right now, just like you just did, except you have to make sure that you're normal and not just normal. But we are normal. 80 on the IQ scale is negative 4/3 of a standard deviation. 90 on the IQ scale is negative 2/3 of a standard deviation. So now you're on the normal scale. So let's do it again. More props, yes. We're still forwards, yes? We're still forwards. We're still between, but now tell it, what's the left number? Negative 4/3. Just put that in as a fraction. The TI can handle that. Yeah, cool. Right bound, negative 2/3. Oops. Hit enter. Aha! That's what's supposed to be graphed, yes. What percentage of people walking around are dull normal?
16%.
About 16% of them. Roughly 1 in 6 people. Roughly 1 in 6 people are walking around dull normal. Which makes me think, what's the matter, Zach? Go ahead.
Nothing. I was just thinking about something else.
Good, please do. Please do. Keep thinking. I like this when it spurs other thoughts as well. Do you guys also agree that if we come over here to, let's call it bright normal, wouldn't there also be 16% over there? Has to be, right, by symmetry. So 1 in 6 people are dull normal. 1 in 6 people are, I'm going to call it bright normal, if that's real. And the other 2 out of 3 people are either here or here. But that's the point is, do you see the mathematics that we did? We had to get off of this scale and onto that one. And that's why your program is called normal. All you got to do is the conversion. If you can do the conversion, you're golden. The conversion is all it takes to get from one to the other. And that was a pretty simple conversion. It was tedious. Yes, it was tedious. Good work on it, by the way, guys, by figuring out that it was 1/3 of a standard deviation and cutting it down. That was fantastic. But that gets messy, because what if it doesn't break up nicely like this one did? This one broke up nicely as 1/3. Good. That's where it would get tedious. Just like we did the chickens by hand first, and then we gave you the program, because it gets messy pretty quickly. We have a nice built-in I want to share with you here in a moment too. Kelly, ask me that question.
Oh, no.
Just taking it in.
Yeah.
Okay, good. Any questions before we move on? I want to make sure this makes sense what we just did. Rob, ask me that question. I got all kinds of false positives today. I apologize. I keep asking for questions that aren't there.
Can you just put the number over 15?
Yes! Yes, hold that thought, JT. Give me 2.5 minutes. I have an example that kind of brings that out. So JT just asked a question. Can't you just put that number over 15? So what he said is, what number is that number? Just out of curiosity.
So you do like 100 minus 14.
Did you hear what he just said? He said, if we do 100 minus the 90, right? That's 10 points of difference, right? Divide 10 by 15, you get 2/3. Make sure you divide in the right order, because it's negative 2/3, right? So what JT is saying is this distance here is 10 divided by the 15, and you get 2/3. What's this distance here? 20. Can I call it negative 20? Is that okay because it's going down? But 20, yes, Michaela, it's definitely a distance of 20. 20 divided by the 15 gives you 4/3. You've just discovered for yourself what's called a z-score. That's the. Remember how I told you I'm going to hide almost all formulas for you in this class? This is the last one that I don't want to hide from you. Is the idea of a z-score. If you can get the distance from average and divide it by the standard deviation, that's how many standard deviations it takes. You just discovered it.
So if it's 2 standard deviations out though, would you still use the scale?
You could, couldn't you? Because 2 standard deviations is 30 points down. Negative 30 divided by 15 is negative 2. That's going to work. It's just that you have those memorized already. You've got the 1s and the 2s and the 3s and the negative 1s memorized. But the formula works for all the things in between too. Fair? Makes sense? Other questions? Jay, you had one I thought. No. You just moved. Just scratched your head. Please.
Where did the 15 come from?
Given. It has to be given to you. Thank you. Very good question. This is one of the things in the original problems. You have to be told that. So first of all, I told you it's bell-shaped by saying it's normally distributed. FYI, normal just means bell-shaped. I don't know why that word got attached to it, but normal means bell-shaped. So normally distributed means you got a bell curve, and then right after that, you have to have the average and the standard deviation given to you. That defines the bell curve. This came up in John's talk yesterday too. It was brilliant, absolutely brilliant. He was talking about flagging people for high hemoglobin levels at the 2001 Worlds. And he was talking about how to use something called a biological passport. Biological passport. What that means is they test athletes at the beginning of their careers, and they establish what are their baseline EPO levels and their baseline hemoglobin levels, and then they test them randomly throughout their careers, and they see if they stay within those limits. To which smartass me responded, Well, how about in the initial tests, you just go in doped sometimes and not doped other times and drive your variability really high. So that way you've got a range like this instead of a range like this. And if you've got a range like this, then you can just dope to get up to that high end. And he's like, you need to sit down back there and realize that they already figured that out and they've already overruled that. The athletes figured that out pretty quickly. That if they just create a wide range for themselves and they can stay at the top part of that range, and the doctors figure out how to crack down on that. But yeah, you have to know what that is to answer your question in a roundabout way. You have to know what these numbers are. Fair? Now, let me show you the power of what these numbers can be. Okay? Y'all know Michael Phelps. Well, maybe you don't. There he is. You might not know Mark Spitz. Let me introduce you to Mark Spitz. 1972 Olympics. 7 gold medals in swimming. These are the individual medals, I believe, I think. Maybe they're teams too. I can't remember. Are they both?
2 teams.
Well, so individual and teams. So who's more impressive? Spitz, 7 golds. Phelps, 8 golds. I love the picture they took of Phelps in 08 with this because it was mirroring the Spitz picture. I just love it. Who's more impressive? JT.
Was Spitz doping or not?
Say that again.
Was he doping or not?
Let's assume they both weren't. We know that Michael Phelps was performance enhancing with marijuana. Which I just find that the most awesome performance enhancing drug. How? Did you put a Snickers bar at the end? How is that performance enhancing? Sorry, Robin Williams joke. Please, Zach.
Spitz has a mustache, though.
Spitz's mustache is way more. That's resistance in the water. He also didn't wear a cap when he swam. Look at that mullet.
He had Speedos.
My first book. Yeah, right. Phelps has the advantage of 3 decades of technology that Spitz didn't have, right? 08, 72. So what's that, 16 years? Excuse me, 36 years different, right? Please, Rob.
Everyone has the same technology.
But everybody has the same technology. But so can we go apples with Spitz and Phelps?
Cool.
Let's come back to that question. Go ahead, Trey.
Didn't Spitz do his in one Olympics and it took Phelps 2?
This was just the 08 Olympics right
Just
here.
the 08.
Oh yeah, Phelps is ridiculous. I mean, he does this like almost every games he's in, except now he's retired, I guess, maybe.
He came out.
He came out of retirement?
Yeah.
He's back smoking weed and competing again. Good for him. Now, I love Michael Phelps. I love both these dudes. Spitz was a shameless self-promoter. He was one of those first like badass swimmers. Like, I'm a swimmer, I'm badass, I'm on Sports Illustrated. This is where this picture came from. I mean, I think it was his idea to do this. So that's why I love that Phelps did it too. You can look at the difference in the faces. I mean, he looks like a little kid. He looks like, I'm gonna take over the world. So anyway, I got some data for us to play with. It turns out these guys had 3 events that they both gold medaled in. The 200 fly, the 100 fly, and I believe the 200 free. Here are the 200 meter butterfly final times in 72 versus 208. So this is Spitz's gold medal heat, Phelps's gold medal heat. Does this help you decide who's more impressive? Callie says no, good answer. Janelle says no. Or does it make it even worse? Makes it more difficult. So here's Spitz. His 1972 gold medal time was 2 minutes, or 2.012 minutes, whatever that comes out to be. Just over 2 minutes. 200 meter butterfly. Anybody swim butterfly? If I do 25 without dying, I'm stoked. So that's 8 lengths at a 25 or 4 lengths at a 50. I gotta stop at the 25. I'm like, I gotta sit here and hang on ropes for a while, like Muhammad Ali getting worked over. So that's 2 minutes. 2 minutes, right? So what's that? I can't even comprehend that. Anyway, so Spitz, Hall, Backhouse, Delgado, blah, blah. The average time in 72 was 2.066. Hopefully that makes sense that Spitz was under that because he won, right? Standard deviation, the plus or minus around it, was a cozy 0.027 minutes. Very, very tight standard deviation, which you would expect. You would expect that, right, in a gold medal round. These guys are all the best in the world competing at one time. So you'd expect a tight standard deviation. Here's Phelps's heat in 08, 36 years later. 1.867 minutes on his best time. Compare that to Phelps, compare that to Spitz. It's like, dude, did Spitz even show up? All the way down to Nikolai's 1.919. The average in their heat, 1.898 with a plus or minus 0.01. Look at that, tight, super tight, even tighter than this one. Anybody see anything worth noting?
Spitz wouldn't have placed.
Spitz wouldn't have even placed in 2008. Look at this. The problem is, apples, oranges. We can't do a direct comparison, can we? So Spitz wouldn't have even placed here, correct? Here's something that one of my students noticed last term that I had kind of missed. Look at Spitz versus Hall. and look at Phelps versus Laszlo. Yeah, oh wow. This is a universe of time difference, isn't it? Comparatively speaking, compared to that. Look, that's 0.037. That's more than a standard deviation difference between these two guys. These guys are off by 100th of a second, right? Which is not a standard deviation. Aaron, what are you thinking of?
Well, I just realized that Spitz is a lot further away from the average.
Thank you, sister. We need a way to put them on the same scale, and I think Aaron has it. What did you do? Tell me what you did. Describe.
I just subtracted the average in 1972.
From Spitz.
Yeah, and then the with Phelps.
Good. Now, there's one other thing you might want to do. You can get away with not doing it in this case, because these are fairly close to each other. So what Erin just did, she subtracted the average from the first place time to get a distance. Just like we did back with the IQ scores. Remember we did that over here? Where we did, oh, it's 90 minus 100. It's a difference of 10, right? But then 10 what? 10, what is it? How far away from average is that? How many standard deviations? What did we do with that 10? Is it 10 standard deviations from average? You see, that's why when you guys put 80 into STANormal, it got confused. When you typed in 80, it didn't think 80 IQ points. It thought 80 standard deviations from average. Do you see why the area was 0 now? 80 and 90 would have put it out to the right 80 standard deviations. So how do we convert exactly? And it's like, oh, okay, that's why it was 0. It wasn't broken. That's even the correct answer. So how do you convert it to standard deviations? You divide by that. Remember how we divided by 15 to get the 2/3 and the third? So what we're going to do is we're going to do the same thing with the swimmer's times. So I did it for you, Aaron. You got me halfway. Thank you, sister. For Mark Spitz, I took his time minus the average time, just like Aaron did. But then I divided it by the standard deviation. It ends up, he's at negative 2.01. That means he's 2 standard deviations below average in that heat. Now, it makes sense that it's negative, hopefully. He was faster than the average because he won the race. Does that make sense? Hopefully that makes sense. Notice I called that a Z. I called it a Z because it's called a Z-score. We just converted what's called a raw score, his time, to a standardized Z-score, which we can then compare against other Z-scores. Let's do the same thing with Phelps. Take his time minus the average time divided by the standard deviation. Look at Phelps. He's negative as well. Why is he negative again? Because he won the race. He has to come in below average because he won the race. But he's only 1.62 standard deviations below average. The more negative you are in this case, the faster you are standardized. So now it's apples, apples, right? Now it's apples, apples. So who's more impressive? In my opinion. Spitz is more impressive. He's more unusually fast, if that makes sense. Is that fair? I'm not saying this is the only way to look at it. I'm saying this is one way to look at it. When you compare Spitz to how he did in his heat, compared to how Phelps did in his heat 36 years later, this hopefully accounts for some of those things you guys put: technology, training, doping even, assuming they were either both doping or both not doping. But even if they were all doping, even if all 8 of the dudes in Phelps' thing were doping, call that a level playing field, right? Sure, the level playing field bell curve's gonna be way the hell over that way, but we're not on that curve anymore, are we? Standardizing it brings it all back to the same curve. Is that fair? Hopefully that makes sense-ish. I couldn't help it. I did the same thing for the 100 fly and the 200 free. Those were the 3 events that they all had in common, yes? The 100 fly, and 200 free. So for 100 fly, Spitz's Z-score was negative 1.68. So 1.68 standard deviations below average in his heat. Phelps' Z-score, negative 1.4. 1.4 standard deviations below average. Who's more impressive in my book? Spitz again. He's more negative, right? This is where it gets tricky because they're negative. He's more negative. That makes him more unusually left, which makes him quicker in my book. It's how I'm deciding to compare. How about the 200 free? This is where Phelps shines. Spitz is negative 1.34. Phelps is almost negative 2. Phelps gets my vote for the freestyle.
Well, that's because of the freestyle. That's when he does his doping with the...
That's when he started doping with the freestyle. Or maybe he was just a better freestyler. He's a huge... Have you seen his feet? I think he's got size 15 feet. He basically is wearing flippers when he's not wearing flippers. You guys still with flippers on? I feel like Phelps when I put flippers on. Do my double kick. I'm like, dude, I'm awesome. No, you're not. Take flippers off and I sink. He's got those biologically. And then his reach, he's huge. And he's got those. I mean, Spitz actually looks like a normal person. Like a normal, like 70s person, you know? Phelps looks like a bat. His lats. And the reach and the pull and all the 36 years of training, right? But the thing about it is that even with all of that being across the board consistent, he still was able to get 2 standard deviations above. Even in amongst those 8 elite dudes in that heat. So what Z-scores allow us to do is to compare apples when we have apples oranges. Or I bet better, it allows us to compare apples when we have grapefruit oranges. If that makes sense. Hope that makes more sense. I've gone 5 over, I apologize. Let's take 5, yes? Let's come back and put this to work. Because this is definitely helpful for us. Let me turn this off. Let me send myself a quick email, because I had an idea while I was talking to you guys. Of course, it's a disease. And I'm going to return some papers, because I have some stuff to give back to you guys. Sir!
Or the.
Hold that thought for 30 seconds.
All right. Well, then. Moving, clear,
Yeah.
So, again,
Yes,
the last 2 questions I have.
don't worry. Wait until the end of the day.
And then I'll be able to go to these.
What we're doing right now will help you answer that. I promise.
Which I think they probably need those. I don't think-
You do.
I don't think I got
You do.
those.
You do need them because you're going to have a hell of a time. Well, I mean,
Yeah, so that's a problem.
it's not a problem. It's just I can't give you the programs, but I can give you commands that you can use. Love the shirt. Let's talk on the class real quick, and then I'll send you the booklet that has all you guys have.
And so what about the projects? What does that mean?
The project's a standalone thing. That's just arithmetic for that.
Yeah, so, okay, I just was having a question for that, because I'm having trouble
Where are your tables?
figuring, like, well, that's why I'm having trouble getting the table. Is because, like,
Well, where is your
all the
table?
examples
Where'd you get stuck?
for the, well, so the first question, so like all examples, you actually have actual numbers, so you have percentages of like 10,000 numbers.
Hang on.
You only have percentages.
We'll change them to
Well, so,
Yeah,
no,
hang on. No. I have percentages in the problems too.
I know, but
There's
there's
a
a
20
10,000.
Then make it 10,000.
Okay, so we just make whatever.
That's what I said in the project.
Okay.
Make whatever number you want. You do the percentage.
I've read through it so many times I never saw anything like that.
This is the whole point of probability, right? Take a large number of trials and apply a percentage to it.
Okay, so I can set 10,000 to it.
Yes.
That I can do easily,
Please do.
okay.
Yes.
We don't mind if our person wasn't gonna say, I'm gonna ask everyone around.
It's okay.
So what did you do? Did you run a disc fill?
You can for sure. Yeah, I think disc's probably the most
See,
direct way of
and
going.
I can do, I know how to get it all into disc fill, but then so you do 0 and 2.
Mhm.
A probability of.
0.5.
But then what do you do after that?
You will awaken if at least
So
one.
I was doing.
You probably
But
were.
then I noticed when I do 3, when I look at 1, the chance was
Not
up.
one, at least one.
So.
Or 2 or 3.
So you have.
Uh-huh.
So I pretty much.
It becomes your first and
so I-
second project.
Oh.
Gosh, that was such a bastard.
I know, I pretty much had it, but I was like, no, that's not
You're
right.
such a bastard. I'm such a bastard. Hi. Yes. You just show me how many you had to get. Now, tell me why you got 7. Did you go into 7 or did you go to 6 first? Did you go to 5 first? Did you go straight to 7? Yes, that's what I'm saying. Make a note of that, or otherwise Francis will take points off. The word, the W on that means show me how you got 7. You didn't go straight to 7.
No.
You started probably at 5, then went to 6, and then went to 7. I got it now. So just make a note of that. I started at 5, didn't work. Went to 6, didn't work. 7 worked.
Okay.
Just make a note. Yes, make it. As long as you don't have the magical answer just appearing there, she's happy, I'm happy.